Hello, my friends. It is Mr. Malzberger. It is time for another wonderful lesson in exponents. It'll probably be noisy. My son is playing games on a computer with a friend. The TV's on in the background as white noise as my wife naps. My dog likes to bark as the neighbors bring in their garbage cans. Today we are going to learn about the properties of exponents. Properties of exponents. Okay, so that's a big fancy name for shortcuts. That's all the properties are. It's ways to get your answer without doing the long work to solve it the full way. Like multiplication is a shortcut for addition. You'll see what I mean. The first thing is going to be multiplying exponents, okay? Multiply. One of our favorite shortcuts in life. So the base can be a number. The base can be a variable. So let's pick 6. Great base. Let's do 6 to the power of 3 times 6 to the power of 4. The long way is saying, well, I have 3 6's multiplied together right here, and right here I'm going to now multiply that by 4 more 6's. And following the rules of exponents, if I total all these up, 1, 2, 3, 4, 5, 6, 7, that would mean I have 6 to the power of 7. That is the long way. Boys and girls, what is the shortcut? You already know what it is. There's 3 6's here. There's 4 6's here. To make 3 and 4 into 7, all we have to do is add. And this is the first property of exponents. When you multiply them, here's the rule. We keep the base. Never change it. Never try and, well, I'm going to multiply and then make that 36, and by one more 6 is going to be 216, then we're going to get 1200. No. Never do that. That'd be 1296, wouldn't it? Just keep it. If it's a variable, keep it. Add the exponents. So that's it. You're memorizing a shortcut. Now, of course, it's not always going to look quite as simple as this. For one thing, we put them in parentheses. Let's do x to the 4th times x to the 12th, right? Same basic thing. Instead of doing a multiplication symbol, a dot, or an x, we put them in parentheses, and you know that things next to each other in parentheses are going to get multiplied. And when we multiply exponents, what are we going to do? We're going to keep the base, okay? So it's going to be x. And we're going to add the exponents. 4 plus 12 is 16. Simple, right? Follow the rule. It does not change. But it's going to get more complex, of course. Let's do d to the power of 4 times e to the power of 6 times d to the power of 3 times e to the power of 2. Now here's the thing. Since we're keeping the base, it means that only like bases interact. Base 6 interacts with base 6. X interacts with x. They do not commingle. 6 to the power of 4 and x to the power of 16 are not going to mix at all. They're going to say, hey, what's up? And they're just going to stand there. They don't merge into something bigger. So when we get here, think of it as kind of like a sorting. We're just putting things back together. We're combining like terms. And we're combining through multiplication. But really, we're doing what we normally do in an equation when we combine like terms, when we have 4x plus 6x, what do? We add them up and say, well, that's going to be 10x. Here, we're adding the exponents. Keep that base of d. 4 plus 3 is 7. Keep that base of e. 6 plus 2 is 8. Let's add on a slight variation. Let's do 4x to the third, y to the fourth, z to the nothing. We're going to put that in parentheses. Let's do 5x squared, y to the sixth, z to the third. Now, obviously, the main difference here is there's more stuff. 2, 4 things now. But each thing is just really one action. And so we're going to find things that go together. D went with D, E went with E. X goes with X, Y with Y, Z with Z. They're separate problems. They affect each other in no way at all. But these guys, let's look at it like this for a second. What if I had 4x to the third times 5x squared? Well, what do you want to do with these? They're not like bases. We can't say, well, this is 4 to the 1 times 5 to the 1. Well, those are just numbers. So really, we're just multiplying 4 times 5. These are like coefficients to this long stream of bases. Multiply these guys. It's always the number in front, and it's always multiplication. So 20, that's your first pairing. Second pairing is the x's. We're going to keep the base of x, add their exponents. 3 plus 2 is 5. Move to the next one, keep the base of y. 4 plus 6 is 10. Okay. Keep the base of z, right? 3 plus nothing would be 3. But that's not nothing. That's something. So what is it? It's not z to the 0. It's z to the what? Z to the 1. This is 4 to the power of 1. This is 5 to the power of 1. Anytime you get no exponent, it's 1. Just like our denominator is 1. The coefficient is 1 on this x and that x and that x. The ones are invisible. So it's not 3 plus 0, it's 3 plus 1, makes z to the fourth. Okay, one last challenge before we move on to your practice. This is going to be a longer lesson because it's just a bunch of stuff and I'm not going to rush through it. Hopefully you're understanding it. Here we go. Let's do like -2 a4 b -3 c, and then let's do 4a2 b3 and c to the -2 parenthesis. All right, let's go in order. First things first, coefficients. -2, 4. Negative times a positive is a negative. 2 times 4 is 8, so -8. We have a matching pair of a's. Keep that base. I've got 2 and 4, which makes 6. Moving over, I've got matching b's, so I'm going to keep that base. Keep the base no matter what. If there wasn't another b to match up with it, you just put it down. I've got an exponent of -3 and +3. And 3 minus 3 is 0. And now c and c, keep that base. I have nothing here, so it's 1. Then I have -2. 1 minus 2 is -1. Now, This is where things get a little tricky. It's simplifying this answer. Is this answer correct? Yes. Is it completely correct? Not quite. So the -8 and the a to the 6th is fine. This b to the 0 is kind of strange. Do you remember what any exponent of 0 does for the number? Like when we did 2's, we had 2 to the power of 0, it equaled what? Remember, 2 to the 1 was 2, and 2 to the 2 was 4. We went by halves, 4, 2, and down to 1. Anything to the power of 0 is just 1. So b to the power of 0 is just 1, right? That's like, you'll see it in the next property when we do division. You'll truly understand this. This is just 1. What is -8 times 1? -8. So when you have something that goes to the power of 0, poof, it goes away. So I have -8, a to the 6th, but I have a negative exponent. Now, if you remember, when we were doing 2's, and we got that 2 to the -1, half of 1 was 1/2. The negative exponent made the powered base go down to the denominator, and the 1 came up to the numerator. It's the exact inverse. This is 2 over 1. This is 1 over 2. 2 squared is 4 over 1. And 2 to the -2 is 1 over 4. They're inverse, right? So that's what this is. This is not really happy up here. What I like to say is all these guys are at the party. B left the party. He's like, I'm going home. But C's not happy up here with -8 and a6. So he's going to go downstairs. And he's going to hang out by himself. Play himself a little Xbox or PlayStation, who knows. That is the simplified answer. Okay, I'm probably rambling today. Here is 6 problems. It looks like a lot, but just boom, match them up. They're simple. You're just adding, possibly subtracting. Pause it, do it, go. We're back. We're doing it, making it fast. What's the rule? Keep the base. Add the exponents. 3 plus 11 is 14. Number 2, keep the base. That's an x. 9 plus 3, that's 12. Done. 3, got 2 different bases here. A goes with A. Keep it, add it. 6. Keep those b's. 3 plus 2 is 5. Good so far? Moving on. Uh-oh, numbers in front. We don't keep them, we multiply them. 3 times 5 is 15. Keep that base of x. 2 plus 6 is 8. Keep those y's. I got a 4 plus a nothing. The nothing is really 1. 4 plus 1 is 5. Moving over to number 5. Gonna multiply first. 8 times 7 is 56. Keep that base of a. I've got a 3 plus a 5, that's a 8. I got a b here and a b there. So I'm gonna keep it. -3 and 4. 4 minus 3 is 1. Then I've got c, a 1 that I can't see, and 7 makes 8. If you were really picky, you could simplify this by dropping that 1 and just making it 56, a to the 8th b, c to the 8th. But you'd really be wanting to simplify. Last one, here we go. -4 and 6 make -24. I've got x and x. 3 minus 5 is -2. And keep that y, ew. -3 and -4, same signs, add and keep is -7. Keep my z's. 5 plus 7 is 12. If you got that, fantastic. What's the simplified version though? The -24, it's over, it's on the top, it's happy where it is. It's on top of a fraction. X is not liking this party. He's like, forget it, I'm going downstairs, and he becomes happy and he's positive. Remember, it's the inverse. He's on top of the whole fraction right now. And when he jumps down, of course, the 1 disappears. Y is not happy up here either. He goes downstairs, him and X are going to have a good time. Z seems to like it up here with -24. That's a simplified answer. All right. Think I'm done? We're not done. Party's just started. Because if you can multiply, you can also what? Sorry. Divide. We're going to divide. Divide exponents. Okay. Need to shift my position here. All right. Remember that things in math, all actions have an exact opposite. So, before we even start, think about the rule that we had for multiplication. We had to keep the base, then we had to add the exponents. Dividing is the opposite of multiplication. So what can we make an opposite in the formula or the rule? Let's check it out. I'm going to start with a numerical base. Let's start with 5. Let's do 5 over to the 6th power over 5 to the 3rd power. Let's expand it and do the long version. 5 times 5 times 5 times 5 times 5 times 5 over 5 times 5 times 5. Now, you know the rule of division. Anything divided by itself becomes 1. So 5 divided by 5 cancels out and becomes 1. And 5 divided by 5 cancels out and becomes 1. And 5 divided by 5 cancels out and becomes 1, leaving how many 5s? 3. You could say, well, that's 125. We're not going to do that. We want to keep things in exponential form. Shh. Sorry about that. He forgets sometimes that I'm here because I'm so stealthy and quiet. Let's keep that 5. How many 5s were there? 3. That's the long way. What's the shortcut? You know it. What did we do? We did the opposite. Yeah, we're going to keep the base. That's always what you do with exponents. You keep the base. That's the whole point of them. We're going to subtract the exponents. Okay. Keep the base, subtract the exponents. Here is the proof that anything to the power of 0 is 1. I had you wait till all the way till this lesson. Here we go. I have x to the power of 5 over x to the power of 5. Let's follow the rule. Keep that base. It's x, right? Subtract the exponents. What's 5 minus 5? It's 0. Now let's go back to this rule right here. Anything divided by itself is 1. So how many x to the 5th powers are there in x to the 5th power? Well, there's one of them. This right here. Anything divided by itself equals 1. And what this equals is x to the power of 0. And therefore, if x to the power of 5 divided by the x to the power of 5 equals x to the power of 0, and x divided, hard to speak sometimes, x to the power of 5 divided by x to the power of 5 is also 1, then x to the power of 0 is 1. That is your proof. If you don't believe me, let's do it numerically. Let's do 2 to the power of 3 over 2 to the power of 3. But let's not do it exponentially. If we did it, you'd say, oh, I'd keep that 2. 3 minus 3 is 0. Let's do this with their actual value, because you know 2 to the power of 3. It's 8. What's 8 over 8? 1. Kaboom. 2 to the power of 0 is 1. All right. Thanks for being patient. Let's do some division, okay? Let's get to the meat of it. Since you already saw multiplication, all the same things are there. You're going to have coefficients, right? there's basically two things that happen with coefficients. You'll have something like this, 27 a squared b to the 4 over 9 a squared b to the 3rd. This is just like the multiplication. You had two things, you combined like terms. This is even easier. We can use our fingers. Each thing is a different problem, completely separate from the other. So 27 divided by 9, that's 3. A squared divided by a squared, right? Keep that base of a. 2 minus 2 is 0. If you already said, well, that's 1, you're right. And would that just poof go away? Exactly, just like in multiplication. Keep that base of b. 4 minus 3 is 1. Simplified, this would just be 3b, right? So same basic rules as multiplication. It's just the opposite. So what are the tricks? Well, the tricks are the negatives and the other things I can do with the coefficients. Let me show you another one. Here's one version. Let's do C3 over C negative 2. And then let's do D4 over D. And let's just give you all of it right now. E to the negative 3 over e to the 2. How does that sound? Okay, this is all of it. This is all the wackiest tricks. Negatives make you have to stop and think. And I hope when you see negatives, that's exactly what you do. Okay, I've got to stop and think here. Negatives change things. They always mess everything up. They make everything the opposite. So this thing here, this 6 over 20, this is a fraction, right? What do you do with fractions? Well, you see if you can simplify it. So 6 over 20 becomes 3 over 10, right? Okay, that's not hard. That's all you have to do. Now, here's what I'm talking about with opposites. We're going to keep that c, because we keep the base. But the rule is if this was just 3 and 2, I would subtract 3 and 2, right? That's what the rule says. It's for positive exponents. Keep the base, subtract the exponents. And that's just the shortcut rule. It's not like something that's not changeable. Negatives change it. They make it the opposite. Now I can show you this another way. If I take these numbers and I subtract them, 3, the top, minus the number on the bottom. What's the number on the bottom? It's negative 2. So when I put it in parentheses, you see we have 2 negatives. So really it's addition. Opposite of subtraction is addition. So when you see a negative on the bottom, know it just switched the rule on you. So I'm going to keep that base of c, 3 plus 2, right? Because this really wants to go upstairs. He's not happy in this downstairs party. He wants to come up and join c, which makes it multiplication. There's your c to the 5th power. Here, I've got 4 and 1, right? It's just the same thing. It's the missing invisible exponent. 4 minus 1 is 3. Then I've got e right here. Negative 3 minus 2, right? Well, that same sign's add and keep. That's negative 5. So that's a negative exponent. So I could either drop it right here, or I could say, well, I already know where that's going to go, and throw it down here, because e wasn't happy at the top of the party. And that's pretty much all the tricks. The only other thing is I could give you a fraction that divides better, like, I don't know, 40 over 50. You say, oh, that's 4/5. If it's a fraction, you simplify. If it's a normal division problem, you solve it. Keep your base. Don't get tricked by the negatives. Time for the exponent practice. All right? Pause it and go. All right, you're back. Here we go. Keep the base, subtract the exponents. keep the 7. 8 minus 3 is 5. Keep the x. 12 minus 7 is 5. All right, so 3 little sections here. 18 divided by 3, that's 6. Keep that y. That's a terrible 2. It looks, especially next to the z, I apologize. 4 minus 2 is going to be 2. Keep the base of z. 2 minus 2 is 0. If you got that, great. Of course, simplify to be 6y squared because the power of 0 is gone. Poof. Number 4, simplify 5 and 15. 1's on top, so it's just going to disappear. So it's just a 5 on the bottom. Let's see what happens with my exponents here. My other bases and exponents. Keep the a. 3 minus 2 is 1, so it stays on top. I can put the 1 or just leave it. B, keep it. 7 minus 9 is negative 2. So where does it want to go? It wants to go on the bottom. And also, if you looked at this, if we expanded 7 over 9, there's going to be 7 b's on top, 9 on the bottom. Cross out 7, you're left with 2 on the bottom, right? So b's on the bottom with its remaining 2. There's that. Divided by 5 is 3 on the bottom. Keep the c. 2 minus 2 is 0. Poof, it's gone, or you could have stuck it here with the 0. 5. 21 divided by 7 is 3. I'm going to throw it down on top. W, 4 minus negative 2. Remember, this is switching it from subtraction. Keep the base. I'm now going to add because it's the opposite. And I get w to the 6th. Got a v, negative 2 minus 3. Well, this guy wants to go downstairs and join him, which should make v to the 5th, right? X, I've got more on the bottom. 5 minus 3 is 2. So 3 minus 5 is negative 2, right? That would give me x minus 2 on top, so I might as well just put it on the bottom. There's 2 more on the bottom. Last one. 15 divided by 17 is 3. J's are going to be j to the 0 power. They're going to just become 1. I've got f. 3 minus 1 is 2. And I've got k. This guy really wants to be up top, so it'd be 1 plus 2. So k to the 3. Okay. Are we done? No, we are not. We have one last property. I'll try and make it quick and not too painful. Okay. This is called raising to a power. Okay. What this looks like is you have a base, let's say 5, raised to a power, in parentheses, that is raised to a power. Now what it's really saying is it wants 7 5 to the power of 3's, or 5 cubes. Right? This is multiplication again. So what's the shortcut? Instead of writing it out every time, there's always a shortcut. I would keep the base and I'd add the exponents. 3 plus 3 is 6, 9, 12, 15, 18, 21. And the shortcut, of course, is 3 times 7 is 21. So we're going to keep that base. That's not how that's the wrong kind of base, isn't it? Yeah, keep the base, not the base, but it's all about the base. Keep the base and multiply the exponents. I'm just going to write expo for exponents. Okay? So, of course, it can be a variable. It can be a number. I'm throwing a lot of variables around. If we get multiples, they're just separate things. It's a backwards distributive property. rainbow it in to the exponents, okay? So this would be x, keep that base, 3 times 4 is 12. Keep that base of y, 6 times 4 is 24, okay? So this one doesn't have that many tricks, really it doesn't. So the only real trick is if I give you a exponent, wrong word, sorry, a coefficient, excuse me. Brain doesn't always work the way I want it to. You know what I mean? You say brain, do this, and it says, I don't know. Okay, so let's do this to the power of 5. Okay. So I'm going to rainbow into all of these exponents, but what am I going to do with this 8? Am I going to do 8 times 5 and make this 40? Does that make sense? Because that would be kind of like, well, if I did 8 to the power of 5, wouldn't that be 8 times 8 times 8 times 8 times 8, right? So what's here? Invisible 1. So that's the only trick. The coefficients now are just going to sit here and say, I'm going to hide my 1. You just have to remember to drop that, whatever this is, right after the coefficient, because it's always times 1. So 8 to the power of 5, a to the power of 4 times 5 is 20, b to the power of 7 times 5 is 35, and c to the power of 5 times 5 is 25. All right, one last little super duper trick. I'm gonna mess you up. You're never gonna know what to do now. Minus 63, that's negative. P to the 4, Q to the negative 3. Let's put I like R, PQR, right? Let's do that 4, and I'm gonna throw a negative power on here. You know what that's gonna do? It's just going to flip everything over. If I put a negative exponent, this just becomes the denominator. Now, of course, what's this guy going to do? Well, he doesn't want to be in the numerator anyways. He's like, this party sucks. I'm going downstairs, right? So if you think of it as this guy is down here, we're going to say, go downstairs. Be happy by yourself. This is going to flip. That's all that's going to do. It's going to say, hey, downstairs, upstairs, upstairs, down. This negative, not gonna change. So, put that negative, this is gonna go, he's on the top, so he's going downstairs, right? So here's my bar. He goes downstairs, he's negative 63. His power is now a 2, because he was a 1. The P, he was happy upstairs, but he's going downstairs with his buddy. 4 times 2 is 8. Here he is downstairs. We'll deal with him later. R is on upstairs. He's now going down. 4 times 2 is 8. Now this guy, he was downstairs. Now he's coming up top. And 3 times 2 is 6. This is just for silliness. So try this last page. I'll get you out of here in under 40 minutes, okay? Promise. You done? Good. Let's do it. Keep that base of 12. 4 times 3 is 12. Boom. Keep that base of x. 7 times 5 is 35. And now I've got double bases, and I am going to distribute. Keep that base of a. 2 times 7 is 14. Keep that base of b. And 5 times 7 is 35. There's my little sneaky coefficient. I'm going to give that guy a 1. I'm going to rainbow, rainbow, rainbow. And 6. 1 times 4 is 4. Keep that base of x. 2 times 4 is 8. Now keep that base of y. And 4 times 4 is 16. Moving right along. He's a negative here. Doesn't really matter in the end. Keep that base of negative 8 and plop that 9 on top. Keep that base of w. 6 times 9 is 54. It's a big W. There's a v. He's a power of 1, so I'm just going to plop in that. Keep that base of v and drop in the 9. That's a really ugly u. 7 times 9 is 63. And oh my gosh, we're almost done. Look at how I tried to trick you. He's got an exponent. It's the old switcheroo. Everybody switch where you are. Top dwellers go downstairs and bottom dwellers come up top. So here we go. That's really what that says. Switch your location. So I'm going to keep that base of 3. He's happy up top, so now he's downstairs. 4 times 3 is 12. A is happy up top. So he's now downstairs with his buddy 3. 2 times 3 is 6. C was not happy up top, so he would have gone downstairs, and now he's up top, right? Because negative 3 times negative 3 is positive 9. Kaboom, you're done in under 36 minutes. Hope you had a great time. Have fun doing the homework number 8. It's really a hoot. Hoot, hoot. Take care. Goodbye.